All right, welcome for part 2 of solving and graphing quadratic equations. This one should go a little bit quicker. So what you see here is what we did yesterday in yesterday's video. So I'm going to scroll ahead to the questions that we did not get to. We did systems of equations graphically. I skipped the inequalities because I threw one in there the other day in one of the other videos. So I'm going to go ahead and do some of the questions that we did not do in the first video. And the first one that I notice here is number 5. So some interesting things happen. Let me pick a different color that's not on this page so we don't get confused with what was yesterday and what's today. If there is a number in front of the x squared and it asks you to complete the square, so in this case there's a -1 happening in front of the x squared. When you have to complete the square, your first move is always still to move the constant to the other side. But instead of just plopping a box in there, like I do for all the other completing the squares, I look at these front two numbers and I ask if there is a number that I can pull out of both. And even if there isn't, but there should be, at least for this level of math that you guys are in, -1 goes into both of those numbers. So what I'm going to be doing is factoring out a -1. Now when I factor a -1 out only out of those two items, I'm left with an x squared, a plus 4x, and then I'm going to put the box on the inside of my parentheses. And then over here, because I moved the 2, by subtracting it, I put the -2 and then another box. The same idea happens to fill the box. I take the middle number, which is 4, I cut it in half, and then I square it. So I am going to put a 4 in this box, but I am not going to be putting a 4 in the other side. Well, basically because I am, to balance my equation, this 4 from this box times this coefficient of a -1 actually means I need to balance it by putting a -4 over here. So now I have -1 times, and then remember, usually we factor something and write it out 2 times, but I hope because we've done a few examples, it's pretty fresh, so I'm going to go right to my factor squared. So x plus 2, all of that squared. That's going to equal -6, but this question is asking us to solve for x. So to solve for x, to start isolating the x that's inside the parentheses, I divide by -1. So I have x plus 2 squared is equal to +6 now. Then I'm going to square root both sides. And when I do that, let me use the space up over here, I get x plus 2 is equal to positive or negative, because you have to have 2 answers, and then the square root of 6. Since the square root of 6, first of all, isn't a perfect square, and then second of all, there isn't a perfect square that goes into it or divides into it evenly, all I have left to do is subtract the 2 to the other side, and my final answer would be -2 plus or minus the square root of 6. And that would be my final answer for that one. In number 6, we're actually going to finally get to practice simplifying a radical. We are going to use the quadratic formula that I have written there in blue. My a is 1, my b is 6, and my c is -2. So x equals -b plus or minus the square root of b squared, so 6 squared, which is 36, minus 4ac all over 2a. Then, as you know, I usually kind of clean it up a little bit, figure out what I call my discriminant. So let me bring up my calculator, turn it back on, clear it out from our last question. Yes, I'm doing all of these videos in one day, so that's why you might see some old stuff I typed in there. Here we go. All right, so the number underneath the radical is a 44. Now this does not say round to the nearest tenth like number 7 did. So that means to me I should simplify the radical. So I need to figure out 44, can that break down to be a perfect square and a non-perfect square? And 4 times 11 is 44, and 4 is a perfect square. So now when I go and write this answer, -6 plus or minus, the square root of 4 is 2. And then if you're one of my students, I usually say check your triangle, but essentially if these three numbers are all divisible by something, then you need to reduce it by that something. So all of them are divisible by 2, so this would be -3 plus or minus, if you want to put 1 in there, you can, the square root of 11, and then 2 goes into itself one time as well. So this would be your final simplest answer. Then you can leave it just like that. All right, we did not get to number 9 yesterday, or whenever you're watching these. So we can do one more, but I almost feel like I should write a question in based off of what you're going to see in your homework. So we'll answer number 9, and then I don't know, we'll see what we can do from there. So let's answer number 9. Hey. It's almost ready to go. Maybe I shouldn't use red. Let's use blue because I haven't used blue on this page yet. So almost ready to go, but by completing the square, I would move the constant to the other side. In its place, I put a box. And if the direction said something like, doesn't matter the order of these things, eventually you're going to combine them together, but sometimes the directions will say complete the square to determine the vertex point. Sometimes it'll say something like algebraically determine the vertex point. This is an option for you if that's what the directions say. It could also say, I'm trying to read ahead. It could just say determine and state the vertex point. So if it didn't say algebraically, then really you wouldn't need to complete the square, but I think it's the nicest way and cleanest way. So take the middle number, cut it in half, square it, so 9 is going in both of our boxes. We didn't have a GCF or anything like the last one did. 7 plus 9 is 16, and multiplies to 9 but adds to 6 is 3. So to get this in vertex form, the last move is to take the 16 back to the other side. You can rearrange it so that it looks a little bit more normal now. I know some of my kids don't like when it looks backwards to them. All right, so now think in terms of your transformations. I noticed that it's going down 16 and left 3. So if it's going down, left 3, and down 16, my vertex point would be -3, -16, and this would be x equals -3. To find the roots, that's when y equals 0, so I would change the y spot back to a 0. And I would solve this algebraically, so I'd move the 16 back over. Square root both sides to undo the x to the second power. So I'd get positive or -4. Don't forget that you always should get 2 answers. And that helps me set up my 2 cases because I should get 2 solutions. 4 is equal to x plus 3 and -4 is equal to x plus 3. And so when I solve, this gives me a 1 and this gives me a -7. So those would be my 2 roots. All right, so lastly, before I kind of end today, something that you might see on your corresponding homework, and I'm erasing the upper corner so that I can use that space. Something that you might see on your homework tonight, or maybe you did last night, is it's going to ask you some things about finding like the maximum height or the vertex and how you could find the corresponding equation. So if I have a sad parabola, okay, let's say it's the trajectory of a ball being thrown in the air or something. That vertex point gives you usually the time it takes to get to the maximum point and the height of the maximum point. So if you can figure out whatever your vertex point is, that will give you basically your x and then your y of your vertex point. Okay, so if you get to a question and you're stumped and you're not sure how to work backwards for it, find your vertex and then see if you can write the equation, which we just did on numbers 8 and 9. So hopefully that helps. And this is a nice short video for you guys today. So good luck on that homework, and don't forget to check out office hours if you have any questions.